Hey everyone, welcome back to Bazai. Today let's break down this diagram and really understand what service mesh architecture actually means without the buzzword fluff. A lot of people throw this term around with Kubernetes and microservices, but if you look at production systems, most of the pain is just services talking to each other in unreliable networks. A service mesh is basically an answer to that pain. It gives you a consistent way to handle traffic, security, and observability between services without polluting every codebase with networking logic. Start with the top part of the diagram, the sidecar concept. In Kubernetes, you have a pod that can hold multiple containers. One is your main app container that runs the core business logic. Next to it sits a sidecar container that takes care of operational functionality, like networking, retries, TLS, metrics, or logging. Both share the same network namespace and can talk over localhost, but the key idea is separation of concerns. The app focuses on business logic, the sidecar focuses on cross-cutting infrastructure stuff. Now imagine not just one service, but dozens, microservice A, B, C, each with its own sidecar. The magic is that each sidecar behaves the same way and runs the same capabilities across all services. You can roll out features like mTLS, rate limiting, circuit breaking, or traffic shaping by changing sidecar configuration instead of touching every microservice codebase. The result is a consistent operational layer across the whole microservice fleet. The bottom part of the diagram answers the question, what is a service mesh? Think of the data plane as these proxies/sidecars sitting next to every service instance. All inbound and outbound traffic from a service goes through its local proxy. Instead of services talking directly to each other, service 1 talks to its proxy, the proxy talks to the next proxy, and so on. That gives you a programmable interception point for every request, which is where the mesh can enforce policies, gather metrics, and observe behavior. Above that sits the control plane, labeled here as the Service Mesh Control Panel. This is the brain. It pushes configuration down to all those proxies, which service endpoints exist, what load balancing rules to use, how to route traffic during canary deployments, what security policies to enforce, etc. You don't SSH into proxies. You declare intent in the control plane, and it handles propagating the desired state across the mesh. At the bottom, you see observability wired into everything. Because all traffic passes through the proxies, the mesh can emit uniform metrics, logs, and distributed traces without each microservice having to implement its own observability SDKs in a perfectly consistent way. You get per-service latency, error rates, request volumes, and dependency graphs for free, which is huge when you're debugging weird cross-service issues in production. And don't forget to like and subscribe to the Bazai channel for more deep dive system and AI content.